In this lecture, we are going to discuss widening of gauge, layout of turnout, site selection for railway station, and maintenance of a railway track. So let's start from the widening of gauge on curves. A vehicle normally assumes a central position on straight track and the flanges of the wheel stay clear of the rails. However, on the curved track, the flange of the outside wheel of the leading axle continues to travel in a straight line till it rubs against the rail. Due to coning of the wheel, the outer wheel covers a longer distance as compared to the inner wheel. This, however, becomes impossible for the vehicle as a whole since the rigidity of the wheelbase causes the trailing axle to occupy different positions. In an effort to make up for the difference in the distance traveled by the outer wheel and the inner wheel, the inside wheel slips backward and outside wheel skids forward. A case study of the running of vehicles on the curves indicates that the wear of the flanges eases the passage of vehicle round the curves, as it has the effect of increasing the gauge on the curves. So I will repeat, this is very important point, that a close study of the running of vehicles on the curves indicates that the wear of the flanges eases the passage of vehicle around the curves, as it has the effect of increasing the gauge on the curves. Thus the widening of gauge on the curves has the same effect and tends to reduce the wear and tear both on the wheel and the track. Formula for extra width on curve. The widening of gauge, that can be noted by small w. So the widening of gauge W on the curve can be calculated by using this formula. And in this formula you can see L is involved. So L is equal to 0.02 into the square root of h square plus dh. W, that is the extra weight that we are going to provide, that is in centimeter you will be getting through the formula. B is the wheelbase of the vehicle in meters. R is the radius of the curve in meters. L is the lap of the flange in meters. Now the lap of the flange in meters means when the train is resting on the railway track. If you just look at the one wheel, obviously the flange of that wheel is in front of the side of the rail. The length which is being covered by the flange, that is basically the lap of the flange. H is the depth of the flange below top of the rail in centimeter. D is the diameter of the wheel of the vehicle in centimeter. So you must be very particular about the units because some parameters, some variables are in centimeters, some are in meters. Now here you would find one problem, numerical. The wheelbase of the vehicle moving on a broad gauge track is 6 meter. The diameter of the wheel is 1524 millimeter and the flange project 32 millimeter below the top of the rail. Determine the extra width of the gauge required if the radius of the curve is 168 meters. So on this particular slide you would find the solution of this problem? Well, here the wheelbase is given, that is 6 meter. And you know, wheelbase, what is wheelbase? Wheelbase of a vehicle is the distance between the adjacent axles of a bogie held in a rigid frame. So that is given, that is 6 meter. D is the diameter of wheel, and that is 1524 millimeters, so obviously 152.4 centimeter. Flange projection, that is obviously below the top of the rail, that is 32 millimeters, so obviously it is 3.2 centimeter. The radius of curve, that is 168 meter, and we are going to determine the extra width of the gauge in centimeter, that is W. Now the solution, we are going to use these two formulas, and keeping this in the mind that L is the lap of the flange in meter, so that is, you can say, the horizontal length which is being covered by the flange of the wheel. So using the equation number 2 first, so you can calculate the length of the flange, and that is coming 0.446 meter, and then use equation 1, formula 1, and in this way you have got the extra width that is to be provided on the curve, that is 3.22 centimeter. And here, yes, you can see that wheelbase definition is given, that the wheelbase of a vehicle is the distance between the adjacent axles of a bogie held in a rigid frame. Now the layout of turnout using Cole's method. Cole's method is being used extensively in Pakistan. The curvature begins from a point on a straight main track ahead of the toe of the switch at the theoretical toe of switch TTS and ends at theoretical nose of crossing TNS. The heel of the switch is located at the point where the offset of the curve is equal to heel divergence. Okay, now look at this figure that is showing the turnout from straight track. So you can see that this is the tongue rail, and rather you can say this is the switch. This is one switch, this is the other switch, and that is the point. If you just look at this V piece, this angle is alpha, that is the crossing angle, and if we extend this line like this, so obviously this angle is also alpha, that is the angle of crossing. So from this point E, if we just look at this one, this angle is also alpha. If you just bisect this angle and just take alpha by 2 over here and alpha by 2 over here and just draw this line, you are having this point T. So you will have to locate this point T in this fashion, that this angle is alpha by 2 and this angle is also alpha by 2. Okay, now look at this figure. Again, this is a gauge, this is the crossing angle alpha, and you can see that we have located this point T over here by considering the angle alpha by 2. So now here look at the different important things. The distance from this point T to this point where you are having the heel divergence, this is called as the switch lead. This is the switch lead. So this is the heel divergence, that is D, and from this particular point where you are having the heel divergence up to the nose of the crossing, this point E, this distance is called as lead. This is called as lead. And then another thing, the distance from this point to the nose, this is known as curve lead. And you can see that here the radius of the curve is r and the number of the crossing, that is n. N or capital X. For the crossing size we can use the capital X or N. Both symbols can be used. So keep this thing in the mind that this distance is the switch lead, this distance is lead, this is the curve lead, this is the crossing size, and this is the gauge. And here we are using N for the number that we are using in the crossing size, and R is the radius of the curve. And keep this thing in the mind that when we consider the radius, this is the radius up to the outer rail. Okay, the notation which is being used over here in this figure: curve lead, that is CL, switch lead SL, lead of crossing or crossing lead, that is L, gauge of the track capital G, angle of crossing alpha, heel divergence D, and the number used in the size of crossing, that is either capital N or capital X, and radius of outer rail of turnout curve, that is capital R. Now the formulae to calculate the various lengths of turnout. So you will have to look at all these formulas. The first formula is meant for the curve lead, CL, that is 2 into G into N. Then you can see the formula for the switch lead, where R and D are involved. Lead of crossing, in this case G, N, R and D are to be used. The radius of curve, that is the G and N, are to be used, and the heel divergence can be calculated by using this formula. And here switch lead, this one is needed, R, radius, and the gauge. These things are required. Now on this particular slide you can see the two numericals. Calculate the lead and radius of a 1 in 8.5 broad gauge turnout using Cole's method. Heel divergence is 120 mm. Calculate the lead and radius of a 1 in 10.5 broad gauge turnout using Cole's method. Heel divergence is 100 mm. You would find the solution of one problem on the next slide. Now here look at that. The size of the crossing is 1 in 8.5. It is a broad gauge case. 5 feet 6 inches is the distance between the rails, and obviously this is 1.6764 meters, so that is G. Heel divergence, that is 1200 millimeter, so obviously this is 0.12 meter. So heel divergence, that is basically the heel clearance, that means gauge face to gauge face is to be considered. L, that is the lead, that is the crossing lead. We want to calculate that one, and the radius of the turnout is also required. So solution begins from here. By using Cole's method, capital X is equal to cot alpha. So what is X or N, capital N, that is 8.5. So you can get the alpha value equal to this. We know the two formulas for L, that is the lead or the crossing lead, and the radius, so you will have to use these two formulas. But keep this thing in the mind, which is very very important, that consistent units are to be used either in meter or feet for different variables. So first use equation number 2, this one, and look at that. G value is 1.6764 and N is 8.5, So you are getting R equal to 244.75 meters. Then use equation number 1. This is, and you can see here G is 1.6764, N is 8.5, and you can see R is 244.75, this one, and D is 0.12 meters. So in this way we have calculated the length, I mean to say L, that is lead, that is the crossing lead, that is equal to 20.84 meters. Site selection for railway station. The proposed site should be on a fairly level ground with good drainage facilities. It should be near to the town or city. Sufficient area for future development or extension should be available. It should be able to serve the needs for the both civil and military authorities. The site should be such that permissible gradient should be easily attained. Construction of permanent way. Land acquisition, earthwork, that means formation, ballast, sleepers and rails, construction of bridges, construction of station building and staff quarters, plate laying, ballast laying. So look at the plate laying. The operation of laying out rails and sleepers over the compacted formation is known as plate laying. The packing of ballast is not covered under plate laying since the formation is allowed to consolidate under the traffic carried out by the railway line. In plate laying, the point up to which the track has already been laid is known as the railhead. The point from which laying of track is to start is known as base. So these are the terms which are being used in the railways. Method of track construction: side method or tramline method, telescopic method, and the American method, which is the advanced method. So tramline method, this method is used when a track already exists, such as doubling of track. The materials required for track construction are carried to the site in material trains. The assembly of the track component is started from one end by the manual labor. This method can be employed for laying of new track. In this case, construction material is carried out on trucks or temporary track. The temporary track is placed at lower level as compared to the main track. The work of linking of track can be started at more than one point. Now, telescopic method. In this method, rails, sleepers, and fittings are unloaded from the material train as close to the rail head as possible. The sleepers are carried either by carts or by the men along the adjoining service routes and spread on the ballast. Rails are carried by rail carrier or by men. Labor working on the laying of track may be divided into three groups: material gang, linking in gang, packing in gang. First, look at the material gang. Their responsibilities are to unload the materials from the train, to arrange the materials item wise, to transport them to the site. The transportation of the rail is a specialized job, and this party is specially trained for this job. Linking in gang. Their responsibility is to fix the rails to the sleepers and link the rail together to the fish plates. The following sequence is followed: marking the center line of track, laying of sleepers, placing of bearing plate above the sleepers, fixing of rails to sleepers, provision of expansion joints, joining by fish plates. Packing in gang. The functions of this gang are to pack the ballast below and around the sleepers, to bring the track to correct alignment and level. Now look at the American method. This method is basically a mechanical method. In this method, special track link machines are used. Pre-assembled panels of track, each panel consisting of rails with appropriate number of sleepers, are taken to the railhead with machinery and is linked. Okay, now we are going to discuss the topic of material depot. In any method of linking, the progress depends upon very much on correct and regular supply of material at the railhead. To ensure this supply, one or more material depots are established. The main depot is usually laid at a convenient site near the point of junction of the new track with an existing railway. Material depot Materials required for the construction of new railway line are received from the material train at the main depot and are arranged at the main depot. The layout should be such that wagons can be unloaded and removed quickly. Mechanical devices such as cranes for unloading heavy materials may also be employed. If one wagon is at the railhead, the other is loaded at the depot. If the distance between the railhead and depot is large, subsidiary depot near the railhead may be established. The stock of the material is so arranged that the correct number of each item is available for loading without any loss of time. The material train should be marshaled in correct order. Okay, now look at the maintenance organization. General manager, divisional superintendent, divisional executive engineer, assistant executive engineer, work manager, assistant work manager. So this is the team which is meant for the maintenance of the railway track. Okay, now gang length and gang men. Gang length is the basic organization unit for track maintenance and is under the charge of gang mate. An average gang length on a single track is 3 miles. The number of gangmen for each gang depends on soil formation, age and condition of track material, intensity of traffic, speed, curves and grades. Duties of various staff. Mate. In charge of railway property in a section, responsible for ordinary work of maintenance and safety of track, controls the gangman, sees the cleanliness and tidiness of track and yards. Keyman. The position of keyman is next to mate and generally takes up the duties in the absence of mate. His duty is to go along the whole section walking on one side and returning on the other side and to check any discrepancies in the track. He is responsible for the inspection of all the fastenings and joints. His tools are keying hammer, bolt hammer, hand signal, flag, etc. The most important task is greasing the fish plates and oiling of fish bolts. Maintenance of permanent way. Permanent way is the railway track. Perception to determine bad running spots. Facility to ascertain the cause of these defects. Regularity of detailed inspection of track to note these defects and to rectify them. Overhauling of the track in accordance with the instruction laid down. So these are the duties for the maintenance team. Maintenance of the track consists of ballasting and surfacing, aligning the track, proper drainage, careful attention to track constituents. Ballast and surfacing. Ballast under the sleeper gets loose and depressions appear with passage of time. The joints, which are subjected to constant blows from passing wheels, are particularly affected. On short formations, the whole rail length gets depressed. The frequency of ballasting depends upon the condition of ballast, riding quality of track, traffic density, and train speed over section. Alignment of track. Due to side movement of vehicle over the track, the wheel flanges exert a side thrust on the side of rails. When this thrust is of fair magnitude, the track is pulled out of alignment. If this defect is not rectified and alignment is permitted to become irregular, the quality gets badly affected. The maintenance on curve is either repacking or realignment. Maintenance on bridges. Special care is required for maintenance of track fastening on bridges. At the junction of bridge girder with the bank, there is a considerable change in the resiliency of track. Sleepers on the bridges are spaced so that derailed wheel cannot fall through. The bearing of girder is coated with oil from time to time. Removal of weeds and bushes. Presence of weeds and bushes is a constant source of trouble to the maintenance staff or team. For proper functioning, the track should be kept clean because presence of weeds and bushes stops drainage, collects and retains dust, which subsequent decay fills the ballast voids and clogs them. Process of overhauling. So different steps you can see. Opening of track, conditions of sleepers, fastening and other fittings, regauging, packing, straightening, drainage, final straightening and packing, boxing, making up of formation. So these are the different, you can say, the steps involved in the overhauling. Tools for maintenance. Beater cum pickaxe to pack the ballast under the sleeper. Rail gauge for checking the gauge. Cant board to provide super elevation. Spirit level and height board for testing cant. Spinners for tightening and loosening fish bolts. Auger for drilling spike holes. Jim crow for bending of rails. Ballast screen, keying hammers, fog signals. Railway track drainage. Increase in the moisture content can considerably reduce the bearing capacity of the subgrade. This may even cause the subgrade to become unstable. The ingress of water in case of roads is checked by bituminous treatment on the surface, whereas for railway it is not possible. Need for proper track drainage. Settlement of embankment. Excessive water may cause the embankment to settle, and unequal settlement may lead to variation in cross levels as well as longitudinal levels, thereby affecting the safety and riding quality of the track. Reduction in bearing capacity of soil. Failure of embankment. Percolation of water increases the weight of soil on one hand and on the other reduces shear resistance. Formation of ballast pockets. Excessive moisture leads to puncture the formation. The constant hammering action of running trains causes the sleepers to move up and down, resulting in ballast pockets, pumping sleepers, and other such problems. Shrinkage and cracking of banks. The embankment soil cracks and shrinks once excess water dries up. This problem becomes acute in the case of poor soils, resulting in loss of ballast in the cracks and uneven settlement. Drainage system. We are having surface drainage system and the subsurface drainage system. Surface drainage. By providing side drains, by provision of cross drainage works, for example, bridges and culverts. So here you can see the typical cross section for the side drain. We are having the track over here, and on the side of the track we are having the side drains. Look at that, this is the side drain. And when you are having two tracks, so one track is over here, the other track is over here, so we can have the open drainage system that is lying between the tracks. That is another option. Subsurface drainage. Seepage water from adjoining area by lowering groundwater table, by using catch drain at the top of cutting, due to capillary action, by providing pervious layer in the embankment, by providing inverted filters. So these are the options which can be considered. So inverted filter. It consists of a blanket of non-cohesive graded material which acts as a capillary break. So basically when you are using the filter, it will permit the seepage, but it will control, it will stop the movement of very fine particles of material. So here you can see that we are having the inverted filter which has been provided, and the minimum thickness of inverted filter is 12 inches or 30 centimeter. Paving of catch water drains. The entrance of water into subgrade can be checked by constructing effective catch water drains that are duly paved. Now the provision of sand piling. Some drainage systems are provided with an adequate number of sand piles of diameter of about 20 centimeter. This improves subsurface drainage. I discussed sand uh, piling in one of the last lectures. So some drainage systems are provided with an adequate number of sand piles of diameter about 20 centimeter. This improves the subsurface drainage. So we can have the arrangement like that we are having the sand piles over here like this at different locations, and it will facilitate the drainage. Drainage of water pockets by perforated pipes. That is another option for subsurface drainage. Perforated pipes having diameter about 30 centimeter are provided at appropriate places to drain off water pockets. And then comes the drainage of water pockets by puncturing holes. In special situations, holes are punctured in the impervious layer to drain away the water. So look at this figure. So you can see that there is an impervious strata, and you know, here the hole has been punctured, this one, and in this way the water which was collected here, that can be drained off. So holes can be punctured in the impervious layer to drain away the water. So that's all for today. So in today's lecture we discussed different topics. We started from the widening of the gauge, we discussed the layout of turnout, site selection for railway stations, and finally we focused on the maintenance of the railway track. Thank you.